All right, so last week we talked about series circuits in a whole lot of detail. And this week we're picking up where we left off, but now we're actually taking this a step further. So just as a quick recap, a series circuit is one in which there's really only one path for electrons to take. And so this week, and especially today, we're really focusing on analyzing and drawing those paths directly on our circuit diagrams. So if I had this series circuit over on this whiteboard on the left of these two circuits, the one path that these electrons have to take, I have no idea what just happened there, would really be this way, where we're going the electrons traveling from the negative terminal of our battery and then going around this loop until they get back to the positive terminal of the battery before they can receive that energy push from the battery again and keep going around this circuit. And we could even say, beyond just this entire circuit being a series circuit, we could say that these two resistors, and I have this in the simulation over here as well, this 10 ohm and this 40 ohm resistor are connected in series to each other because any electron that goes through this 10 ohm resistor must also pass through this 40 ohm resistor. There are no choices or anything, and I say choices, of course, even though these electrons are not making decisions, but any electron that goes through one resistor has to pass through the other one. There's no other option or no other available route for these electrons to take. Now today we're contrasting that with what we are going to call a parallel circuit. And that's what I have over here on the right part of the simulation and on the right side of this whiteboard. Now you can see that if we trace the electrons through this battery, when they get to this point, some of the electrons will come through this 40 ohm resistor and some of them will take the path through this 10 ohm resistor. We're going to talk in detail tomorrow and for the rest of this week about some of the implications of that, like of the fact that there are multiple paths for this to take. But today we just want to make sure that we are solid on identifying the different routes that current can take through a parallel circuit. So if I'm over here and I want to draw all of the paths that are available to our electrons in here, let's start at this terminal. So the electrons come out here, they're going to have to go here. And at this point, I'm going to stop because as soon as we get to sort of this intersection in our wires, now our electrons have, and I'll put in air quotes again, a choice as to where they go. So some of them will go through this 10 ohm or this 40 ohm, based on what I have over here in the simulation. Some of those electrons will go through this resistor, and some of them, and I'll do this in a different color now, some of them are going to go straight there, right? And if I'm following this purple path, I have to keep going this way. Electrons never turn around. That would be like if you drop an object, it's falling down, and all of a sudden it starts falling upwards. The electrons will, just like an object as you drop it, they'll travel in the direction of decreasing potential energy. And now instead of gravitational potential, it's just electrical potential energy. So they're going from this negative terminal, and they want to get closer and closer to this positive terminal, which is like the ground in our dropping analogy. But they're not going to turn around. That would be violating the laws of physics unless there is some kind of energy source that would be pushing them back, in which case we would have a much bigger issue of circuit safety on our hands. But we keep tracing these electrons. They don't have a choice at either of these corners, so they're just going to keep going around in this direction. And now when we get here, right, it looks like there's another sort of intersection where these electrons have a choice if they want to make this left or if they want to keep going straight. The issue and the reason that they will never go left here is because some of the electrons are already going this way to the right through this part of the wire. So these electrons that are taking this purple path, the longer way around through this bottom resistor where I have this 10 ohm resistor here, are just going to keep going up, and all of them are going to do that. None of them are going to make this turn to go left. And if you wanted to sort of see that in real time or in a slightly more realistic setting, you can actually use the simulation and you could observe all of these electrons that are traveling here. None of them are going to go sort of upstream or against the current that's flowing within this orange path for those electrons. So let's finish up drawing this orange path too. And in the same way, none of these electrons that are traveling in this sort of shorter orange route around the circuit, none of them, when they hit this intersection, are going to turn and start heading down, because these purple path electrons are already moving up, and it doesn't make sense for our electrons to travel sort of in the direction of increasing potential energy. Again, that would be like an object falling upwards, which objects don't do. They're always going to gravitate from a higher energy situation to a lower energy situation. It's more stable for them. And that's really all of what we're doing today, is tracing these paths on a parallel circuit, because that's what makes these parallel circuits special, is that now there are multiple paths for our electrons to take as they go from this high energy terminal where they're pushed out of the negative end of a battery until they get back to this positive end, the positive terminal of our battery. That's contrasted with a series circuit where there's really only one path around that circuit. The only other thing to keep in mind is that initial definition that I gave, where even in a parallel circuit, you could imagine a case where, and I'll do this over in the simulation here, I could bring over another resistor, and then I might have resistors that are connected in series to each other, even if we have an overall parallel circuit, right? So now I've got a parallel circuit. There are choices for these electrons to follow, but I could say that this 40 ohm and this 10 ohm resistor are connected in series to each other. So that's the main goal for today, is to identify those paths and identify aspects of series circuits even within parallel circuits.